All right, so we are in Algebra 1, Lesson 2-9, Multi-Step Linear Inequalities. Today's date is Tuesday, September 22nd, 2020. We just have one homework assignment on Khan Academy tonight. The objective is so easy, I'm just going to do it. It's just to solve those linear inequalities. But what is a linear inequality? Before I discuss the word linear, let's just talk about the word inequality. So it's an equation, just like you're used to. But the equal to sign is changed to some other sign. So I'm going to get a bunch of quiet raised hands here to help me out. What is one of the signs that you think I'm looking for? And you can make the symbol with your hands if you don't know the name of it. If you know the name of it, even better. Zeke, yeah.
Greater than.
Greater than, perfect. I need another one. Let's go with Ripley.
Equal to.
Not quite. So the equal to is replaced with something else.
Greater than? No,
I already have greater than.
Less than, sorry.
Less than, there you go. Yeah, let's go with Yesenia. We can't hear you. I know that you're unmuted, but I still can't hear you. Weird. Maybe just talk louder.
Less than or equal to.
There we go. Less than or equal to. Let's go with Alden.
Greater than or equal to.
Greater than or equal to. Ooh, and what about the last one? What has been mentioned? Yeah, Giorgio.
Not equal to.
There it is. That's an equal to sign with a cross through it, not equal to. Yeah, you guys got this. Okay, this is going to be a super, yeah, and you got the symbol using your pencil to cross it out. Nice. Yeah, perfect. So those are the signs that we're going to replace. So anytime you see those, you don't use the word equation, use the word inequality. It's like equation, but not an equation, right? Inequation is almost the word here, but they changed it to inequality. You have an equality and an inequality. So these things are strictly not equal to. I mean, some of them are kind of equal to, but also greater or less than. So let's go ahead and do the signs. You've already heard students say them, so let's go through them really quickly. A less than means the alligator, I guess, is chomping to the right if we're in elementary school, right? The bigger number over here, I have a bigger number over here and I'm trying to chomp on that big number. Less than or equal to means I have the equal to sign underneath it. So it's just a line underneath our symbol. We have a greater than or equal to, and then we have a not equal to. Cool, and I guess I did kind of give it away that I have these things down here, didn't it? But make sure that you have an understanding of a few ways that you could use these. So I can say that 1 is less than 2. That makes sense, right? Now, you can please make your own example. Don't just copy mine. Make your own. And you can do a few examples too. So I can say 1 is less than or equal to 1, which is true because 1 is equal to 1. But I could have also said 2 is less than or equal to 100. So there are two different ways of saying that. Just know that it is also equal to. Greater than, pretty straightforward. 3 is greater than 1. Again, don't copy my examples. Make your own examples. Greater than or equal to, you can do the same thing. 3 is greater than or equal to 1, but you can also say 3 is greater than or equal to 3 because it is also equal to. And just anything that isn't the same, you're good. So 1 is not equal to 3. If you want to be fancy, you can say cool symbols. You can say like pi is not equal to phi, all these symbols that you maybe have never heard of. Just kind of curious, with a quiet raised hand, how many of you have heard of pi? The symbol pi. Okay, all of you, it looks like. What about phi? P-H-I. It's not P-I, P-H-I, phi. Phi is the cooler number and it gets no respect. All right, we'll talk about him when we get to geometry. Unless you guys can somehow distract me with a tangent and be like, I really want to know about phi. I will be willing to go into a whole lesson on phi on the spot. All right, so I have a symbol here just to make sure that we're all on the same page. The bigger number is always going to go where the alligator is chomping. So if you want to draw teeth on this big symbol, you can say that the alligator is trying to eat the big number, and it doesn't care about the smaller prey, some animal, I guess, some small number over here. I'm always trying to chomp on the big one.
What if the arrow just points at the smaller number?
Okay, yeah, that's another way to remember it. It's always trying to point at the smaller number. However you want to remember it, that is perfect. Yeah, so I'll go ahead and do Jose's analogy. So I can go like this. I can do an arrow like this. Oh gosh, the lag is making it so I can't color things in. I'm not moving. My hands are up. Whatever. So I'm just going to do an arrow like this. It's trying to point at the small number. Wow, I'm getting a crazy amount of lag, which is making it harder to draw. The arrow is pointing at the smaller number. All right, perfect. So this is kind of cool, right? So do you guys all agree that 7 is greater than 5? You can nod your heads, yes. Nod your heads, yes. 7 is greater than 5. We understand that, Mr. Snell. We passed kindergarten. So here's something that's kind of interesting. Again, because these should follow the same rules that we're used to, I should be able to add 1 to both sides, right? And you don't have to do this in your notes, but just watch what I do. Don't draw this down. Don't write this down. Watch what I do. So if I add 1 to both sides, plus 1, then I get 8 is greater than 6, which is also a true statement. 8 is greater than 6. Okay, so adding to both sides works. Subtracting to both sides also works. Multiplying should work. Let's test it out, right? So again, don't draw, just watch. So if I multiply by, I don't know, 2, multiply by 2, I get 14 is greater than 10. Okay, yeah, looks good, right? You're giving me the thumbs up. Okay, yeah, that makes sense. You can multiply. Here's where you get in trouble. Watch what happens now. I'm going to multiply by -1. Multiply by -1. And this one I do want you to write down. What happens when we multiply both sides by -1? Then I have something that looks like this. I have -7 because -1 times whatever just flips a sign. So -7 is greater than -5. And this might be kind of hard for you guys to see, but if you look at a number line, it's a little bit easier, I should say. If I look at a number line, here's 0, -1, -2, -3, -4. Here's -5, -6, -7, and there's -7. So -5 lives right there. -7 lives right there. And when I'm doing these inequalities, this greater than, I'm really asking if I assume the positive direction is on the right. So I say positive direction is on the right, the negative direction is on the left. And I'm saying I have to be greater than a number. It's really asking I need to be a number that's farther to the right. Well, originally 7 was farther to the right than 5, but now -7 is not farther to the right than -5. So this is now false. So we're not allowed to multiply -1 on both sides. And you guys can probably see ahead since you've already copied down most of these notes. And the same thing happens, right? You guys can all agree that, yeah, -6 divided is definitely less than or equal to 4. You guys can all nod your heads. Yeah, -6 is a smaller number. It's like, it's more to the left. It's in the negatives. Again, what if I divide both sides by -2? Divide by, instead of saying the divide symbol, I can just
Can we write that one down?
Yeah, go ahead and write this one down too. Divide by -2, divide by -2. If I divide both sides by -2, a negative divided by negative is a positive, so I get a +3 here. And this 4 divided by -2 is -2. And the sign you just bring down, that's our rule before. It said if we had an equal to sign, just keep copying that equal to sign down. But this is not true. It's saying now 3 is less than a negative. 3 is on the right and a negative is on the left. That doesn't work either. That's false. This is not a true statement. So multiplying and dividing by negatives, that there are bad things that happen. We have to create our own rule to fix this. And you'll hear this over and over again because you'll have me as a teacher for another 3 years after this. There's this theme in all of mathematics history where we try to make corrections, or we try to make our systems work. Like multiplying by a negative, it doesn't work. Okay, let's find a way to make it work and have our rules be consistent. Eventually, I'm going to say, oh, you're not allowed to take the square root of a negative. And eventually, the class after that will be like, Okay, let's let you do that, but let's go ahead and make a rule to make that work. We're all, like, that's the theme of all of mathematics. Let's try to make it work and have this be consistent. So this is our dipping our toes into that pool. Okay, so let's go ahead and say, okay, well, maybe the sign just switches. If it was a less than, it turns into a greater than. Or if it was a greater than or equal to, it switches to a less than or equal to. It just kind of flip-flops the sign. It was pointing this way, now it's going to point this way. Or it was pointing this way, it's going to point that way. It doesn't change the fact that it was an equal to or not equal to. It just changes the direction that's facing. That will only happen when? What did I just say? There's only these two scenarios that will make you have to switch the sign to make sure that you're still correct. So I'm looking for an operation. If you do this operation or do this operation by a certain type of number, that's when we need to switch the sign. What operations do we do? Do we add? Do we subtract? Do we multiply? Do we divide? Do we take the square root? What operations do we just do up here that cause us to need to switch a sign? Yeah, Ripley?
Divide.
Yep. So if you divide, oh, so that was this side over here. We divided by something. We divided by something. What's another operation? Someone else. What was the other operation?
Multiply.
There needs to be a quiet raise hand, Zeke. But yes, you are indeed correct to multiply. Okay, so whenever you're dividing or multiplying, you need to have like that spider sense going off in your head, like, ooh, I need to be careful. Because if I multiply or divide by a certain type of number, then I need to remember to switch the sign. And what type of number do I need to be careful of? Alden?
A negative number.
Exactly, a negative number. Okay, this just needs to be like burned into our brain right now. You're going to need to switch the sign, switch the direction of the sign if you ever multiply or divide by a negative number. And Zeke, Jose, and Carlos, if you could turn your cameras on, I'd appreciate it.
Sorry.
All right, so like just repeat that over and over in your brains. Let's try it out. So example number one, we need to solve for x. So you're going to be doing the same thing on both sides. And just remember, only when I multiply or divide by a negative, that's when I need to split the sign. I might not have that, but if I do, I need to switch it. Okay. So what are we going to do? We'll do this one together, and then I think there's an example two on the backside that you guys can try on your own. So example number one, how are we going to do this? Help me out. This is a we do. Then it's going to be a you do. Anyone have a first step? Again, the general strategy, we want variables on one side, constants on the other. Sorry, Ripley. Sorry, Alden. I'm going to give it to someone new, someone that hasn't spoken as much, I should say. Yeah, Diego?
One thing we could do is either switch them around to have 4x minus 2x or add 4x minus 2x.
Or add 4x minus 2. Oh, yeah, like somehow get these two together.
Mm-hmm.
How would I do that? Well, because there's this inequality symbol. So I have to do the same thing to this side and this side of the inequality symbol. What do you want to do to both sides?
Add 2x to both sides.
All right, let's do it. Add 2x to both sides, add 2x to both sides. And you might have started doing this problem a different way, which is fine. There's a bunch of different ways to solve it. This is just one of them. Okay. So Diego, can you read out our new inequality after we add 2x to both sides?
It would be 6x plus 23 and greater than 11.
There it is, yeah. And good job getting the symbol name right. Okay, now what do we do? Yeah, Haiti.
Subtract 23 from both sides.
Subtract 23, and that's going to be a little bit difficult on the right-hand side, but I think you've got it. So can you tell me what to write now?
6x plus 23 minus 23.
Oh yeah, so after I do 23 minus 23, what do I have?
6x greater than negative 12.
Oh, nice. Negative 12. Perfect. And I guess I shouldn't scroll down too much. Very nice. Thank you, Haiti. And what do I do now? Jose?
Check your answer.
I can't check my answer quite yet because I haven't solved for x. How do I get x by itself?
Divide
By
by 6.
6. Okay. Divide by 6. Divide by 6. Can you go ahead and read the inequality now?
X is greater than 2.
Yeah. Okay. Yeah, Alden?
Isn't it negative 2?
Oh, why is it negative 2?
Because it's a negative 12. If you divide 6 by
Yeah,
negative.
negative 2.
Ah, yes, it is a negative 2. Okay. Yeah, thank you for fixing that. And just as a general rule of thumb in my classroom, I'm just going to write down whatever you say. It might be wrong, it might be right, but I'm hoping that your own peers can correct each other. So thank you for catching that. And I see that Jose sees that too. Nice, good job. You guys see it. Wait, does that mean I need to flip the sign? It's a negative 2, and I divided, right? Let's do this. Quick poll. Should we flip the sign to make the greater than turn into a less than, or should we keep the sign? So option 1 is let's flip it. Option 2 is let's keep it. Everyone hold up 1 or 2. Should we keep it, or sorry, should we flip it? Flip it is 1, keep it 2. Flip it, keep it. Flip it is 1, keep it is 2. Curious where you guys are thinking. The majority of you guys, Zika's saying 3, 5, I don't even know. The majority of you guys have it. It's 2. You don't need to flip it because look, we just divided by a positive. If we divide by a negative, we would have had to flip it. But we divided by a positive, you're okay. Yeah, so that's our final answer. And we can go ahead and box this. And on Khan Academy, sometimes they want you to, oh, weird square happened. Sometimes they want you to be able to graph this too. So it's important to know how to do that. And do I talk about that? I must talk about it. Oh, it is down here. Okay. Ooh, I don't know if we're going to be able to get through all of this lesson today then. We don't know how to graph this yet. I will come back and graph this later. I'll teach you guys how to do it at the very end. But give me a fifth. Oh yeah, question, Zeke.
Wouldn't we add like the like greater than or equal to under it because it's x is the negative 2 or no?
No, so the equal to will only be there if it was originally there in the problem. So if there was originally an equal to, we just keep copying it down. But since there wasn't, we just keep copying down it without the equal to. Yeah, that's a great question. Thank you.
Okay.
All right. Let's try solving the next one. Example 2. There's no more questions. No one's raising their hand to get more time to write this down. Okay. Let's try this one. So everyone has it written down. I'll give you guys a few minutes to try to solve this. Does someone want to give me their first step? I see one hand. I should see a bunch of hands, I would hope. I would like to call on someone that I've never called on before today. So thank you that you've already raised your hand. I haven't talked to Braden, Carlos, or Ashley. I think those are the 3. Okay, so Braden, Carlos, or Ashley, first step. What do you want to do? Quiet raised hand. Who wants to do it?
Subtract 25 by both sides.
Okay. But next time, if you could do a quiet raise hand, I'd appreciate it. Yeah, but subtract 25, you said, from both sides?
Yeah.
Minus 25. Minus 25. All right, can you go ahead and read the line after you subtract 25 from both sides?
Would be negative 42 y plus 54. And then it would be 25 would cancel out, and it would be y equals 11.
So does this match what you have on your paper?
Yeah.
Okay. Looks like I have a few hands. Yeah, Yesenia? Uh-oh. You're not muted, but I still can't hear you. I don't know what's going on.
I don't know. I think it's like,
There it goes.
okay. Is it negative or positive, the 42y?
Oh, I don't know.
I think it's positive, right?
It should be a positive 42?
I think.
Okay. What do you think, everyone else? Can you give me a thumbs up, thumbs down? Quick, come to some consensus. Should it be a positive, thumbs up, negative, thumbs down? Everyone's saying positive, thumbs up. Okay, so it should be a positive. Yeah, that's correct, because if I have a bigger positive and a smaller negative, it should be still a positive. So I'll come back here and erase that. All right, good catch. Yeah, thank you. Oh, okay, so sometimes this makes a mistake. If I scroll down and back up, it should fix it. There it goes. Okay, there is another mistake, a tiny little mistake that we can fix in here too. Does anyone see it? Jose?
You have to subtract negative 54 on both sides.
Oh, the next step is to subtract 54 on both sides?
I mean, add
Yes.
54.
Wait, say it one more time?
Okay, I meant to say subtract 54 from both sides.
Oh yeah, so for the next step, you are correct that we're going to be subtracting 54 from both sides, but we need to make the correction first. There's an error in this line that we need to fix. So I'm going to do that step right after we fix the error. Yeah, Giorgio?
The y came down. Like you just subtracted the 25, but you didn't add the y.
So what should the correct answer be then?
It should be less than or equal to 11. Just 11 on the other side.
Got it, okay, yep. So the one thing I want to point out is when we subtract the 25, we're really subtracting the entire 25y. So to correct this, we can say subtract 25y, subtract 25y. Because now it's a like term. Now we're allowed to actually subtract these to get the 42y. So that all looks good. And then when I have a 25y and I say subtract the 25y, those should cancel out to give us nothing down here. So I can go ahead and select this y to get rid of it. And that means I really need to just copy down this negative 11. So instead of saying equal to 11, I can say it should be negative 11. And I also need to copy down this sign. This inequality symbol is going to be copied down over and over and over again. So this is a less than or equal to, so I should also have a less than or equal to. All right, so now this line doesn't have any errors. Yeah, good job. You guys all work together to get this. Perfect. And then, as Jose said, we're going to subtract 54 on both sides. So subtract 54, and we're almost out of time. I have a minute and 10 seconds left, so I'm going to kind of go a little bit faster through this. Subtract 54 on both sides. That means that the 54 is going to be canceled out. I have 42y is, I'm going to copy down the same inequality symbol. It was a less than or equal to. It's still a less than or equal to. And then over here, I have these two numbers are going in the same direction. So I'm really adding them. It's really adding these two negative numbers. So I have negative 65. Okay, and then I'm almost done. I'm going to do the final step for us. I have this 42y. I'm going to divide by 42, divide by 42. That leaves me with the y isolated is less than or equal to, and I can't simplify these numbers. They're called co-prime, which means there's no way of dividing the top and bottom by 2 or by 5 or any number. There's no number that you can divide them both by except for 1, and they're co-prime. Can't do anything. Negative 65 over 42. And sometimes you will get a fraction on Khan Academy like this, so it's okay. It doesn't always come out to a nice number, and frequently it doesn't. You're just statistically looking at your problems. All right, we are not done with these notes. Do not do the homework. There is no homework for tonight because the homework requires you to do all these notes. No homework. We'll do notes maybe tomorrow. We'll see. I think tomorrow's going to be primarily just getting all of our systems in place. Maybe we'll do like 5 minutes of notes just to finish up these notes. We'll see. I'll see you guys in class tomorrow, again in room 2, in Mr. Brown's room, the science room. Mr. Godoy will talk to you about how to do that, and I'm frozen.
Yep. No, I could hear you.
You can hear me, but okay, cool. Questions before you guys head out? Zeke?
Do we have to do the other examples or no?
No. Stop
Okay.
doing what you're doing right now, and we will finish these later. Yeah.
Okay.